from Dinner Minds. Today is the second session of Daily Dose for Chemistry, and today we'll be discussing the 11th MCQ from 2020 A-Level Chemistry paper. So, this is the question, and the question says, consider the following compounds, and they have given 5 organic compounds and their relative molecular masses. So, if you look at, so you have to choose the best shown variation of boiling points of these compounds. So when it comes to boiling points of organic compounds, so we can compare the boiling point using intermolecular forces or using their relative molecular mass or molar mass. Molar mass or relative molecular mass. So you all know that when it comes to intermolecular forces, when their strength increases, the boiling point also increases. So there is an order for the strength, and so the hydrogen bond is the strongest intermolecular force, and the second strongest is dipole, and the weak intermolecular force is London dispersion force. So this is how the strength of intermolecular forces of organic compounds varies. And when it comes to molecular mass, you all know when the molecular mass or the molar mass increases, the boiling point also increases. So this is how we can compare the boiling points of organic compounds. So when we look at these 5 compounds, the relative molecular masses of all the compounds are almost the same. So therefore, the relative molecular mass is constant here. So we have to compare the boiling point using intermolecular forces. So when you consider A and B, you can clearly see A and B are alkanes, and C and D are aldehydes because of the CHO group present in the molecule. And E is an alcohol, so you identify it by the OH group in the molecule, right? So in alkanes, we look at the intermolecular forces present in the alkanes. So there is only London dispersion force in alkanes. So in aldehyde, we have dipole, and London dispersion force. And in alcohol, due to OH group, the hydrogen bond is present between the molecules. And in addition to that, we have London dispersion force. So you all know that London dispersion force is present in all the molecules, regardless of its polarity. Okay. So now, after finding the intermolecular forces present in each molecule, so now you can compare the boiling pointers for a certain extent. So if we compare the boiling point, so you'll know the boiling point of A and B is less than the boiling point of C and D. And the boiling point of C and D is less than E, right? So this is how the boiling point varies. So here you can clearly see that the boiling point of C and D should be greater than the boiling point of A. So now we can neglect, or we can get rid of the 5th answer. So it won't come as an answer because the boiling point of D is less than A and B in fifth answer. So now you have to choose an answer among the other four answers. So so now let's compare A and B. So in A and B, only London force is present. And so the difference between A and B is branched and A is unbranched. So when molecules are branched, their surface area decreases. Therefore, the strength of the London force also decreases and the boiling point decreases. So then, therefore, the boiling point of B should be less than the boiling point of A because B is branched and A is unbranched. So from this, you can neglect the answers. The third answer can be neglected because it shows the boiling points of A and B are equal. And also you can neglect the fourth answer. So now you have only two answers. So if we compare B and C, C and D. So in C and D also, the D is branched and C is unbranched. Therefore, the boiling point of D should be less than the boiling point of C. So in that case, we can easily neglect the first answer because in the first answer, the C and D have the same boiling point. Therefore, the second one is the answer, right? So if we compare the boiling points, so B has the least boiling point, and then A, and then C, and D, and E has the highest boiling point. Okay, thank you for joining us, and we'll meet with another MCQ on another day.